Okay, now that we're calibrated in terms of making sure there's no bias in our sensors, we're ready to actually input the calibration coefficients so that we can convert dielectric to air void content. So if we go back and go into mix calibration and we select new calibration, we're going to name this calibration. This calibration is actually from yesterday. So this would be 6-22-PUX, because this calibration is from PUX, and then we also put a C there if it's been validated with core locations to be correct. So we're going to press enter, and we're going to specify that we want percent compaction, which is percent GMM. And then I actually just took a picture of the Excel spreadsheet coefficients. You probably won't be able to see it with the camera, but we have A is 24.1 and B, which is our slope, is 12.7 for this specific mix. So we're going to put that here. 24.1, enter, and B is going to be 12.7, enter. And the only other thing we're going to put here is that this is a straight line type of calibration.
Okay, I'm on the project site.
And now if we press save, we'll be able to look up that specific core calibration file name. So now when we go back and we're into our project, we go into asphalt mix calibration, 622-PUX-C, and we're going to save it, save successful, and go next. Save. And now Nick's going to walk us through a joint pass next, and we'll be able to look at the actual live percent compaction as we're going along the pavement. Okay, now that we've entered our mix calibration, we can go into our measurement type, and we're going to be doing field measurements in distance collect mode. Nick is putting in our starting station, which is 70 plus 00, which is also indicated on our GPS, and increasing westbound. And now you'll see he's changing his lateral offset from reference line to cart to 2 feet, because we have our center sensor 2 feet to the left of the center line joint, and that's going to put our rightmost sensor 6 inches centered away from the center line joint. We still keep our same lot and file name designations, and we're ready to actually collect, but first, since we changed our mix calibration, we're going to go into display options, and we're going to change this to display percent compaction. So now when we push the cart forward, instead of outputting dielectric, it's actually going to give us the live percent compaction of this specific pavement. Go ahead and press save, and we're ready to collect data. After a short warm-up period, now Nick is going to start pushing the cart forward, and you can see if he's dragging the zip tie along the joint that rightmost sensor is just measuring consistently 6 inches away from our center line joint, which is what we're trying to accomplish with this pass. We're also getting a 2-foot and a 3.5-foot offset, which will help us fill in our full lane width. Okay, Nick has made it about 243 feet now on our joint pass, and I just wanted to talk a little bit about what you can look for as you're doing these live collections. So the first thing you want to see is your live measurement. And this is a pretty representative measurement of what we're seeing here, where our left sensor is about 92.98, so about 93% compaction. Our center sensor is 93.17, also about 93% compaction. And our right sensor, which is 6 inches away from the joint, is down at 90.05 compaction. And this is what we're trying to monitor and to try to improve upon, is making sure our joint compaction does not have deficiencies. So with that in mind, you might be able to see that these little lines going across here, generally speaking, the black line and the blue line are just hovering around 93% throughout this 240-foot pass that Nick has collected. And that's also indicated by this greenish yellowish color here on the upper two color map points. What you see below that is the right sensor, number 305. You have a dark spot there and a dark spot there. This corresponds to these little dips below 90% compaction that we're trying to minimize when we're doing our construction of the centerline joint, of course. And this is a nice tool to be able to monitor that joint compaction, and you can see real time these low spots coming in and trying to figure out, okay, how can we eliminate these low spots to build longer lasting pavements. Nick has completed his joint pass, so you see he's turning the cart around and getting it set up to come back with a 6-foot offset pass. And again, our 6-foot offset pass indicates that our center sensor is 6 feet to the left of our centerline joint. We're still on the left side facing up station, and that's one thing to remember when you're putting the input of the offset. And if it helps, go stand on the center line joint, and instead of facing the direction you're testing, which may or may not be up station, you face up station and look to see, okay, I'm 6 feet to the left of the center line joint, and that's what you put into your software. And that indication is independent of the direction of paving, it's independent of the direction of traffic. The only thing you care about is what is the direction of up station and where is the center sensor relative to the center line joint. So now Nick is ready to start his pass back at a 6-foot offset. Okay, so now that you saw Nick has turned the cart around and centered our center sensor 6 feet away from the joint, you can see that he's done two things. He's put a check mark here to say we're decreasing, which means we're moving in the decreasing stationing direction on this pass. And then also, he's changed our lateral offset from reference line to cart center to 6. Before it was at 2 when we had a pass at 6 inches, 2 feet, and 3.5 feet away from the joint. Now that we're at 6 feet away from the joint with our center sensor, we're filling in with a 4-foot, or with a 4.5 foot, 6 foot, and 7.5 foot offset from the center line joint. And the software will automatically calculate where each of the sensors are and what direction we're going. So we're actually good to go to press collect. And now in this screen, it's ready to go, and it's going to actually start pushing in some data here as soon as we push the cart forward. Okay, we're now ready to do our final straight pass, and for this one, our center sensor is 10 feet away from the center line joint. So this pass should include 11.5 feet, 10 feet, and 8.5 feet passes to complete our full coverage straight pass measurements. And what we're doing here is actually using our station and our offset from our live GPS readout, because the lane width is actually a 14-foot lane, and we only care about the 12-foot max density lane for the purposes of our measurements. So we're making sure that we're 10 feet away with our center sensor according to our alignment file, which tells us both our exact offset and station of our sensor. So now Nick's actually going to go in here and put all the necessary information in, which includes a 10-foot lateral offset relative to the cart or to the center line, and we're ready to complete our last straight pass forward. So here Nick goes on his final straight pass, and as you can see here, the leftmost sensor is not 6 inches away from the joint because our lane is actually wider than our 12-foot max density lane, and he's just going off of his live station and offset measurements on his GPS to tell him where he is relative to the center line.